Let's start with a basic multiple regression model. We've got two x variables, two independent variables in our model, x1 and x2. You'll notice that we don't have an error term out here this time, but instead we've got this e open parentheses y close parentheses. Read this as the expected value of y, and you can think of it as the predicted value of y. On average, our error term should be equal to 0. So our predicted value for y is just given by this formula, where beta 0, beta 1, and beta 2 are the intercept and slope parameters that will be estimated during our multiple regression process, and x1 and x2 are our independent variables. For now, let's assume that x1 and x2 are completely separate from one another. They're unrelated to one another. Then as x1 changes, x2 stays the same, and the effect of x1 on y only happens through this slope parameter beta 1. Let's think about what each of these parameters, beta 0, beta 1, and beta 2, mean, how we can interpret them. Our intercept coefficient, beta 0, we can think of as being the expected value of y, the predicted value of y, when x1 and x2 are 0. Think about what happens in this equation if x1 and x2 are 0. It doesn't matter what beta 1 and beta 2 are, these terms both go away, and we're left with just beta 0. Usually, this is not of interest. It's usually not interesting what the predicted value of y would be when x1 and x2 are both 0, because that's usually outside the range of our data. But it's good to know what beta 0 would mean if we needed to interpret it. Much more interesting are our slope coefficients, beta 1 and beta 2. Each of these tell us how the predicted value for y will change as x1 or x2 increase by 1 unit. Usually when we're interpreting a multiple regression model, it's these slope coefficients that we're interested in. Let's first think of x2 as being 0. If x2 is 0, then this term goes away, and we're left with just what looks like a simple linear regression model. The predicted value for y is equal to beta 0 plus beta 1 x1, slope coefficient times the value of the independent variable. But now let's think about raising the value of x2 by 1 unit. As we raise the value of x2 by 1 unit, x2 increases from 0 to 1. Now, our estimated value increases from beta 0 plus beta 1 x1 to beta 0 plus beta 1 x1 plus beta 2. Because now x2 is 1, beta 2 times 1 is beta 2. Our predicted value for y went up by beta 2. This confirms for us our understanding of what the interpretation of beta 2 is. It's the effect of a 1 unit increase in x2 on our prediction for y.